So we just had a great question to start it off, which was, how do you guys know each other? What's the working relationship? How do we describe that relationship together?
How do we pair? Why are we working together?
Yeah, and so we know each other both through Oblong and through our studio practice. It started with Oblong. We
work on the Client Solutions team.
Yeah.
So Client Solutions does a lot of like early prototypes, early product development, a lot of client work. It's right in the name. So clients come to us with, I don't know what they come to us with.
Either data viz problems or narrative problems to talk about some complex issue or service that they offer, and trying to find some interesting new immersive way to talk about the work that they're doing. And so,
immersive is usually.
I'm sorry, I think you're not familiar with Oblong Industries.
Oh, okay.
So if you could give a little bit of a background.
Sure.
Yeah. So do you guys know Minority Report? That's probably the easiest starting point. Yeah. Have you heard of John Underkoffler before? I heard a lot of you know Kate Hollenbach as well. So Kate was actually my boss at Oblong before she started school and teaching. So Kate and all of us work for John Underkoffler at Oblong. He founded the company after he worked on all the sort of gesture and science-based sequences in Minority Report. And
we're going to show a video of it. When Tom Cruise is doing like these kinds of motions in front of a bunch of 3D-esque systems.
Exactly. Yeah. So he founded that. A lot of that work in the movie with Spielberg was based on his research at MIT Media Lab. He did that work, and it got. I think he would have done it with or without the positive response, but it got such a positive response, and he said, geez, we're not that far away from this technology being reality. So he started the company and started to explore some of those ideas in it and bringing that sort of science fiction to life. And so that's a lot of what we work on right now. There's a couple different aspects to the company. We have a product side that offers Mezzanine, which is sort of a next generation conference room info presence system. And we have our solutions team where we do a lot of custom work. And so something that happens a bunch is a big client will come to us and say, we're interested in a couple of these conference room systems, but we'd also like an experience center next to it that interacts with our conference room systems, and you move data around and where in between and all of them, just like you can in the movie. And so that's a lot of what we work on. It's the custom component of it.
Typically these complementary immersive spaces have a lot of pixels, and oftentimes the clients want to tell very specific stories that they can bring their customers on through and be like, this is why you should invest in us, or this is why you should buy our products, that sort of stuff.
So this is great. I think we're hoping to have, I'd love if our whole conversation or our whole presentation was conversational. So like raise a hand or shout out if you have like thoughts or questions all the way through. There's probably going to be some stuff that I talk about and assume you guys know about, like what the company we work at is. And we'd much rather, I'm kind of hoping this whole thing is a conversation with you guys.
We're excited to engage in everybody here.
So anyway, here's some relevant details on us and links and stuff, and we can probably put that back up on the end. Oh, right, the topic of our talk is spatial computing, gesture, and windows into virtual. So this is the thing we work a bunch with, and we're going to kind of talk about each one and how all of these things together offer interesting opportunities in data visualization, immersive design, immersive artworks, and sort of the next generation of how humans interact with technology.
Maybe just some background on like how we met.
Oh yeah, that part too. Okay, so Justin and I kind of like Justin right away from the start, because I would come to him and be like, hey, I'm doing this prototype. So a lot of my role at Oblong is to prototype and do the initial exploration for design on our client projects. And so I'd go off and try to do something like some LiDAR visualization with 2 million data points or something, and I'd get it to kind of work, but I'd have about half the data that I needed, and I'd be getting 5 frames a second on my my runtime, and I would come to him and be like, hey, this is sort of right, but I'm a designer, I'm an artist, I know how to code, but like that's not my area of expertise. Do you think you can get this thing working? And sure enough, I don't know. The next day, I had this thing running at 60 frames a second that was loading 4 times the amount of data that I had, and I was like, all right, awesome. And sure enough, 2 days later, I'd break it again and have too much, I'd broken the system that he'd spent all this time on and made sort of, like, the code always comes back to me beautiful, like, and everything from formatting to comments, it's super accessible. And then of course, once I have these new capabilities, I go off and I use them to break things again. So it's a really great relationship.
It's this back and forth, it's this iteration. And it's to be expected, right?
We both have like mutual appreciation for the other's capabilities. There's a there that I know if he does something that it's going to be, it might not be the ultimate approach that we use to the engineering solution, but it's going to be a good one to start with. And I think he trusts me to, sometimes go on instinct or some of these artistic qualities, right? These gut feelings that this might be a right direction, even if I can't particularly explain to him why this might be the right solution. He feels good about, at least going with it.
So we would do this back and forth at work constantly, right? Where the stakes are, hey, like you actually have to show this prototype to a client, right? And it's not really acceptable if it's running slow or it doesn't actually meet, we can get 5 million points running, but they wanted 20 million points, whatever the metric is, something silly. So we kind of developed this back and forth relationship at work, and then John was working on a project for his art practice, and he kind of, this one, and he came to me and said, hey, do you want to work with this on me after work?
Yeah.
And I said, yeah.
Yeah.
And this is, at work, the designs and the prototypes would be they're abstract, but they also have like a lot of business application, right? A lot of it's more like on the data viz side of things, and it can't be too artsy or too abstract because there's some Fortune 50 client that's paying me to make sense of it. I was really excited to work with him outside of work because everything was more abstract and artistic, and that wasn't something I had ever really been a part of. I come from a pure math background. My first job out of college was doing simulation and modeling, a lot of Fortran, C++, that kind of stuff. And so getting the opportunity to work with him in a more artistic capacity was really exciting. And it was something that I was excited about.
Yeah, it's fun. There's different constraints. When you're doing art, there's a different set of constraints, right? There we're dealing with there's some similar constraints, but we don't have a client. Like we're the client. It doesn't make up what we're interested in and want to pursue. And
you kind of get to define your search space, if you will, and discover different parts of that search space that is pleasing to you. And pleasing is a metric that you can't necessarily define.
Yeah, I do both find that our art and design practice informs our oblong work quite a bit, and vice versa too. It's interesting. There's one little example in this project that we'll see where I've been working on a prototype for an interface at Oblong, and it gave me an idea for how to approach sort of the ending of this project. But, any questions on that or thoughts? Okay, let us know anywhere through it. So spatial computing is kind of the first one that we wanted to address, and there's a lot of different, I think that can address a bunch of different things. So for me, one of the things spatial computing addresses is writing code in 3D space and time, right? That's a simple one. So these are some sketches from just exploration of ideas and looking at, the one on the left is this little flower that I saw over the summer in Oregon, and the one on the right is kind of an abstraction that I was thinking about some glass vases that I'd been looking at. And
what do you use what programming language do you use for all these?
So a lot of these are in processing. A lot of our work at Oblong is C++, and happens with GSpeak, which is a spatial operating environment. It's a library in C++ that has a bunch of conveniences. But a lot of my studio practice, or a lot of my own explorations and a lot of our studio work's been in processing so far. Because it's great, it's just really accessible. That's what I grew up with, and that's what I learned at Design Media Arts. So.
And I was happy to kind of indulge in whatever framework he liked. I think part of being on the more technical side of it is being adaptable and being able to put yourself in any situation and adapt and figure things out.
Yeah, there was a lot of cursing from him, like it's like what on earth, like Java, grr, but it was fun. It was entertaining. I mean, I also teach processing because I think it's just a really accessible, easy way to talk about code with people that are don't have a CS background. So, Yeah, so again, these are spatial studies. These are a couple studies for a new project we're working on at the Arboretum, which is a newer version of, but this is, I mean, there's some similar ideas. We're still thinking about space and texture and interaction and responsiveness, but this is kind of a different, this will be a direction for us to go from the previous projects. So that's kind of, again, these are in processing. We also do a lot of data viz. So this gets more into the sort of design world, but this is a collaboration with a researcher at Children's Hospital who's looking at heart formation data and individual cell migration. And again, this is in processing, and here I'm yeah.
You said at Children's Hospital, like the one CHL?
Yeah, CHL. So Rusty Lansford.
What's his name?
Rusty
Rusty
Lansford. So Lansford.
Okay.
So he's also he also teaches at USC. He also teaches at Children's Hospital, but he's a researcher there. And yeah, he and I were friends at Caltech. I first worked in the Biological Imaging Center. So Scott Fraser, who's at Caltech now. When I first moved to California, I worked with David Kramers, who is the Caltech conceptual artist, who is based out of Scott Fraser's, where Rusty worked. And Rusty and I became friends. And when I started working at Oblong, we discovered there were a bunch of really neat opportunities for data visualization and immersive design with the tools we had there. So this stuff is all still sort of very locally based. This work tends to just live on a laptop or in print, a PDF or something like that. But some of the work we'll look at later on will be sort of the other end of spatial visualization or analysis.
I think that's like one important point to hone in on is that a lot of the work we do, we prototype on laptops, right? These 2D screens that exist right here. But ultimately where we want to showcase our work or deploy our work is in much more interesting screen space configurations. And you'll see that a little bit later in the talk.
Yeah, what did you say that this was? It was like a...
Yeah, so this is a quail heart. These are individual cell migration routes for the quail heart, the developing quail heart. So it's about 7 hours of data, and it's a couple 100,000 data points.
Wow.
Yeah, it's really fun. I mean, one of the things I love to do in my work is to really push things to the point of spatial complexity where it's difficult to follow going on. And that's one of the neat things about data right now, right? We can collect so much data, there's so much information out there that I think novel methods for interacting and visualizing it are important to explore. So
in the images, like, what is it showing? Is showing the flow of the blood, or?
Yeah. So this is the same data, and it's not quite blood flow. It's more migration of cells as they form the heart, so as they form the valves or as they form the atrium. So this is looking at the cells as they migrate on their route. The idea, the sort of goal of the research is to, when the heart takes shape, it kind of turns one way or the other, and in one direction you get a healthy organism and a living creature, and in the other direction you typically have death fairly quickly. And there's catastrophic cascading effects from this one little moment. And they're interested in understanding that and in an attempt to treat it and to help children and humans that develop this condition. And so the initial research is just to sort of visualize and see what's going on with all these cell tracks to identify potentially interesting tracks or cell sets to look at. The kind of next stage goal of this is to start to include genetic expression and different metadata with it to help better understand like what's going on in the system and how to treat it and how to address some of these issues. So it's cool stuff. Are you in science or just?
I'm just
interested.
Yeah. Yeah, and so this is basically like the like a newborn that's like growing, and then to find out where it's sort of like having something wrong in the growth process, and you're visually able to see that like pattern.
Yeah, so this is a quail model for it. So this isn't a human model. Yeah, it's exactly. The idea, the models are similar enough that we can learn about it here.
Interesting.
Yeah, it's really, his data is kind of incredible. Like it's one of the reasons yeah, I've enjoyed working with him, and it's just that they're able to gather such kind of amazing information. They have a focus on collecting information from living systems, living organisms, and not like killing and staining and fixing stuff. So, yeah, their work's really incredible. Okay, so on the one hand, there's like spatial computing in terms of 3D, 4D data viz design and artwork, and on the other, I think on the other end of that spectrum is some of the work we see here. It's large scale, lots of pixels, lots of computers, lots of screens, immersive systems, and this is our work at Oblong. So.
This is actually one of our client staging environments. So we have a client that has a couple of systems that look very similar to this, deployed all around the world. They ask us to build. I kind of call them like marketing stories essentially. They're essentially trying to bring clients into these spaces and sell them on some product or just investing in them, right? So they want to tell a story and they want to wow the clients. So this is a great space to do that because it's fairly large and fairly interesting.
Yeah, and it's really neat to be able to work as a designer in these spaces because I can design for space and put it out there and then use all these screens as a window to look into them. So we'll talk more about this kind of stuff as well. And then so one of the other topics, gesture. When I talk about gesture, I mean anything from simple optical flow stuff, right? So like this to.
Our airport came calling, and it desperately needed a solution to the question of.
That's John talking here, and these are kind of fun. I hadn't seen these before I worked at Oblong, but there's all these really cool studies that he did. The research is based on a lot of really rigorous science and study in gesture, and how that can be used as an interface to pixel computer systems. And I think that's one of the themes we'll keep talking about too, is this ability to write code to interact with space and to interact with pixels in space is an incredibly powerful thing and has led to a bunch of really new and interesting ways to look at information and interact with it. Yeah, so that's a classic scene. So then from that to this, right? Like a lot, I mentioned John founded Oblong to make that technology a reality. This is another visualization of Oblong. It's looking at earthquakes and it's all gesture based. There's a single sensor. In the middle, it's similar to the Kinect. It's a 3D sensor, and we've got a gesture pipeline that recognizes a number of gestures, like open hand or fist or one finger or two fingers. And when you have the ability to recognize those forms in space, you then have the additional ability to move and follow translation and turn things like this gesture and translation into a rotation. If I can follow. If I've got, hey, you move that hand to the left 10 inches, that's going to translate to 280 degrees of rotation. Yeah.
So basically you're like creating a language. Are you creating the language or are you programming?
He creates it. Like,
I mean, that's actually a very good description of it, right? Like, in some ways there's a lot to discover, right? Because we have this gesture pipeline that can recognize it. So we have code that's like, okay, when the camera recognizes that you're doing this, some function's going to get called and it's like, oh yeah, they're making the closed fist gesture. But it's on you to actually say, okay, now that I have the closed fist gesture, what am I going to do with the pixels on the screen, right? Like I have some system that I want to visualize, I want to interact with, so what does that gesture mean? And that's an opportunity for John to say, okay, I want these gestures to do these things, right? So building a language is like a description of what it is.
It's teasing a little bit, but like Justin didn't write the pipeline we're using here, but he creates these tools that give me incredible power as a designer to take advantage of space and pixels, and just makes it really easy for me to intuitively think about the things I want to be thinking about, like what should this visualization be, how should I break it up into space, how can I use space to interact with it in a new way and see new things and get new glimpses of information.
I definitely consider like my primary job to make the technology and the programming invisible, and to allow John and other designers on our team to accomplish whatever their vision is, right? I mean, this is a room full of computer science students students, I'm sure you guys have done some amount of programming. You've had to deal with systems and text editing wars. Your favorite programming language, your least favorite programming language, right? There's tons of things in tech that are just so orthogonal to creating this, even though it's all technology based, right? Like this is technology, it's all programming, but at the same time, we have designers that say, I want to be able to do this, right? I have this vision, I want to visualize this, and a lot of the technology is just kind of this thing that sits in between. It's the implementation detail that doesn't really matter. And we'll talk about that more throughout our talk.
So for that case, do you have to specifically stand on that location in order to have it scanned?
Yeah, this is very similar to a Kinect. It's just a depth-based camera, and so this is capturing frames at probably 30 frames per second, and the system gets those and then analyzes that data to determine, oh yeah, there's a person in the shot that's making this gesture and it's at this XYZ location in space.
There's two really good questions there, right? So one, the gesture interaction, two, the visualization and the viewpoint, right? So we've got a system here. I think it's just one computer running all three screens. There's different resolutions. One of those screens is a 4K screen, and I think two of them are HD. But we're doing G-Speak has a bunch of tricks in it that allows us to show pixels and information based on, I can get the resolution of the screen and the size of it and the fact that they're offset. I can do a bunch of really neat things. But yeah, there is a limitation of the camera's in pretty much the perfect view here, right? Because we've got non-coplanar angled screens. You can design around that a lot of the time. Like this has a pretty good field of view and you still get the 3D sense from different areas, but the optimal point of view is where you are.
Yeah. If any of you are taking some courses in computer graphics or are interested in video games and video game programming, typically you're setting up a perspective projection for your screen to render into. This particular setup has 3 perspective projections, right? 3 different frustrums where there's like a central camera. There's going to be a frustum pointing at this screen, a frustum pointing at this screen, a frustum pointing at this screen.
Did that sort of answer your question?
Yeah.
Okay. Cool. So we'll keep going. But gesture also means things on the phone, right? Like a lot of people think, I keep seeing stuff about gesture and I'm like, oh awesome, I'm going to see some big gesture thing. And it's like, oh, okay, no, we're doing something down on the phone. And I think there's definitely a place for that, right? There's different gesture interfaces for different things, right? This is a really cool demo that a guy named Alex Valley did at Oblong, where he, that's my favorite part. The official version of it doesn't have him clapping at the end, but he finally got this thing working. It's running on 4 different machines, 1 Linux box, 1 Mac laptop, yeah, like a tower. It's ridiculous, and he's controlling it all with his phone, right? And but that's what technology should be. That's one of the goals of Oblong, is that
Making it transparent.
Yeah.
Everywhere.
all these pixels should be accessible to the creator, the designer, to people. They should be able to walk in a space and share their information in it, right? So, yeah, Alex is awesome. I learned a little. I first paired with him when I started. He's a really good guy. He's in now. Right, 2 wands. This is our key method of interaction right now at Oblong, and you know, the gesture-based stuff's super cool and it's really neat. But when you have a whole room and you have things like people holding coffee mugs, like a fist to the 3D sensor looks an awful lot like a coffee mug. So if you've got multiple people in a space, really quickly it becomes difficult to get spatial input. And the wand is an amazing piece of hardware that gives us true spatial tracking and true spatial input that allows me to do proximity-based things. I'm doing like a flashlight simulation here. It's a pretty simple idea, but my beam is changing based on how far away from the wall I am. And right, I can stand in one place and I can move around and I can interact with the data in different ways. We'll show you how this is actually useful and interesting later on towards the end of the project.
Yeah, just to clarify, the wand is actually working through ultrasonic emitters. So this, you might have seen this in the earlier picture, but there's a giant cage up here that has a bunch of receptors, and the wand has these little microphones on it. And essentially that's how G-Speak is able to essentially capture the position, orientation, and pointing location of that wand in this 3-dimensional space. and we're able to use that to point at these non-coplanar displays. One advantage of the wand over something like gesture is, with depth cameras, pointing is not precise. You can't precisely point at a location down to a couple centimeters. With the wand, we're able to get centimeter-esque precision.
And just to additionally clarify, like I'm in videos, but this isn't just me, right? There's a big team that Justin leads that allows me to create these experiences that answer a ton of questions and help me through dev and stuff like that. So I'm in a lot of the pictures, and it's always it's kind of funny to go through these presentations because it isn't just me, but I'm the lucky person on the top that gets to use all these tools that are being created. Okay, so here's another kind of fun gesture. This is that same heart visualization, but here we can do spatial tracking again. So similar to the hand gesture, I can get even more precise information from the wand and do things like push through time. So there I'm actually pushing through the cells as they migrate over their 4 or 5 hour track. It's pretty.
This is on this is showing it on a 40-foot display wall that we also have in various client centers across the world.
Two fun Arduino-based stuff. So we this is a class of Pete Hawks, who's the design director for the solutions team, and I do at USC. And we look at new forms of interacting with technology. It's a tangible media course, and this is great. This is an Arduino proximity sensor-based multi-wand, and Mike is going through and interacting with it and putting his hand on different sides and just driving this big system. So one of the projects we always do is create an Arduino project that can interface with our system and run. Here's another great one, speaking of gesture. So the feathers are totally necessary. I don't think it works without it.
And the construction.
And the construction hat, which got pulled out of the warehouse. But she's got flex sensors on these little feather things she's built, and when her arms are bent in one way or the other, she goes up or down or left or right. And this is still one of my favorite pieces that one of the students has come up with.
And the GoPro, you cannot do it without.
Yeah, no, you have to have the GoPro up there too for they did a good job with the video stuff too. But I kind of love this too because like you sit there and like there's a point where she flies into the building and I still kind of like respond to it, like because when you're in that space and you're moving like that, it is really immersive and really responsive. That's one of the neat things about all these technologies we explore for interacting with virtual systems. And one of the really cool things about GSP connecting us to this virtual world in new interesting ways is that there's a very like concrete connection that you have to these virtual spaces using a lot of this stuff, whether it's gesture or the wand, and it's a really exciting way to design, and I think it is one of the features of how we interact with pixels.
Yeah, I love this example because I was commenting earlier about how you have this opportunity to provide inputs into the system and then describe what those inputs mean, and how many people have worked at Oblong for how many years, and this prototype's been around and not a single one of us thought of this.
Yeah.
Right. It's great. And maybe this isn't something you're going to ship to a Fortune 500 client, but it's pretty awesome. Right? It's exciting. It's like this cool little discovery. It's neat, and it feels really good to watch. I didn't actually use it, but I'm sure it feels really good to use. It's just like a really rewarding feedback system, right?
Yeah, I mean, it's one of the reasons I love teaching is like you guys are coming up with these great ideas that we would never come up with. I mean, it's a different. It's awesome to be able to pass along the tools. I mean, I pass along the tools to create this stuff and to see what people come up with is just really fun and rewarding. Okay, so I think we're on the Windows into Virtual Worlds one. So this is from a studio work from like 10 years ago before Justin and I met. But one of the things even before I was working at Oblong, was thinking about was dematerializing surfaces in order to think of them as volumes. So I didn't think of this wall as a projection surface, even though it was. I was interested in the space behind that projection surface and the space I was able to define for this artwork to live and exist in. That lended itself directly to this project that Justin and I worked on at the LA Arboretum 2 years ago, 2016, where we like quite literally made a volume in the garden that mirrored and responded to things that were going on there. All the way up to actual windows into virtual spaces again. I know we just talked about that a second ago, but working at Oblong in these spaces is kind of like being in Neil deGrasse Tyson's Ship of the Imagination, right? Like I can write code and put it out there, and all of a sudden I can fly through it and interact with it and be immersed in it. This is that hard data again. So.
Has anyone taken linear algebra here? Computer science students? You should take your linear algebra. Take your linear algebra. I promise you, you won't regret it.
Only if they go into spatial computing, or like?
That'll be useful. It'll be useful in general, but yeah, for this type of work, it'll be very useful.
Justin's pretty. That stuff's totally beyond me. Like we've had. I know, I kind of understand it when you explain it, but like it's still.
I mean, just to like give some more context, when John he keeps talking about spatial computing and windows into virtual worlds, right? What's really happening in this type of system is that all these displays are actually positioned in this. So we define this arbitrary coordinate space around us, and we say, the camera is at 0, 0, 0, right? This screen is at 10 meters over this way, right? It's 10 meters wide, 5 meters high. I know my units are wrong. I'm an American. I'm sorry. Right, but you actually place these things in physical space, right? And then you have this wand that you actually know the orientation and the position and where it's pointing in that physical space, so you can make these physical coordinates. And that's very different than you opening up a web page on your laptop, right? It's very 2D. It's not spatial. It's just always going to be there. Yeah.
So basically, you're saying when you program, you kind of acknowledge the space that you have, and you're trying to work whatever he designed and kind of bring it to the screen like that over there.
Yeah. If you have any experience like doing web programming or maybe doing some maybe a little bit of game dev, a lot of times you define things in terms of pixel space, right? You'll say my thing to be 0, 0 is the top left corner, and however many pixels wide by however many pixels tall is my bottom right corner. You'll position everything in pixel space, right? This is very different. This is actually positioning things in this physical space that we've defined and that you're operating in. And so a lot of the challenge on the technical side is, hey, how can we make it easy for someone like John or any artist on our team to actually bring their ideas to life?
Yeah, so noticeably absent so far, and we won't really get into it because I don't have a ton of experience in it yet, even though it's one of the things we're looking at is like things typically thought of as augmented reality or mixed reality, right? And I think Josh is next week, right?
2 weeks from.
2 weeks, okay, yeah. So Josh is an amazing guy, and we'll talk to you about some really great stuff. But the three of us have had coffee and conversations lately about how do you deal with pixels in space, whether it's a mixed reality lens in front of your face,
right,
or
goggles on your face,
right, or in this environment, and thinking about those coordinate systems exactly like you're bringing up, like, hey, we've got a physical space, like. How do we connect the pixel space to the physical space and make sure all of those screens and pixels are calibrated is a big question right now, and there's definitely opportunity to grow and develop in. So I think it's something a lot of people are thinking about. I think there's definitely a component to that future with the work we're doing at Oblong. I think the spatial coordinate system we have is really good and allows us to do some really exciting things. And I think. Yeah, I'll let Josh talk to you more about his take on that, but I think there's some really interesting opportunities for interplay between these systems and interplay between these pixel systems and how they communicate and all the talk with each other. So one last, just to go inception on you, if that's a verb, but one last Windows into Windows is a prototype where Alex and a couple people worked on this, where you could not only have a window into a virtual world here, right? So this big world exists, but we have computers, we can place computers' views into the system as well. If you look here, he's grabbing the computer that's running the screen and moving it around here. So each of these computers is aware of each other, is sharing information, and is sharing perspectives and views. So you can do something like walk into a space look at it, see where other people are looking, right? This is kind of, you see this in video games, right? I know you can sort of see where people are angled and targeted and stuff like that. But the ability to go in and drag them and move them around and change perspectives is kind of a really exciting thing. And it's one of the things that G-Speak does really well, is share that information between systems and between computers and shares view and that ability to share views and stuff. So that's just kind of one to end on. This is a really exciting demo that I think I'd love to see us continue to explore. Okay, so that was kind of part one where we just talk about all the stuff that we're going to be talking about. Here's part two where we dive into a specific project to sort of show you
the creative process.
Yeah, creative process.
Back and forth that goes into it, the design side of it, the technical side of it. This is the final result.
Yeah, at the LA Arboretum in 2016. So I haven't done this before. There's going to be a lot of I haven't shown a lot of stuff we're going to show you before. One of the things I always liked as a student was to see the experimentation and the development and the stuff that didn't make it into the final product. Because you see the final thing, you're like, oh, cool, that's awesome. Like, yeah, but what about all the stuff that didn't work or that broke or didn't, you know, what was the evolution to it? And so we're going to look at some of that stuff tonight because, like I said, that's some of the stuff I always found really interesting. Yeah, so this was our final piece, or the sort of final piece of the Arboretum a couple years ago. It was based on these flowers, these trees that I saw at the Arboretum. So we got asked to do it. We went out there, and I right away fell. I was captivated by these trees, these Lagerspermia trees, and the spaces in them were really interesting to me. The sort of spatial ambiguity when you stood under them and looked up into them, and branches in the foreground versus background, and again, there's this spatial complexity to it, right? There's all these branches, there's all these leaves, there's all these flowers, and when the wind blew, they were all in movement and changed in relation to each other. Like that was really interesting to me and kind of an idea that we talked about and explored from the beginning. And this was our site. There's two really neat monumental walls at the entry of the Arboretum, and this is sort of the final work in place there. So where did this start? This piece started, it was actually called Kaleido. I don't know if you can, it was originally called Point Cloud Geom because it was purely Kinect data. And I started multiplying it, and right away this is where I started running into the issue, right? Like it's just a Kinect sensor. I've got what 640 by 40, I think, resolution. And
so the Kinect has like a depth camera in it, and every 30 times a second, it's going to produce this 640 by 320 matrix, if you will, of depth data. Like how, for every pixel that the camera on the Kinect sees, how far away is that pixel from the camera, essentially.
Yeah. And I think maybe Justin's the only other person that's ever seen this stuff, but these are like the really early studies where I was like, oh yeah, I don't know why I was interested in kaleidoscopes, but it was, and the Kinect data was interesting. And I only had 640 by 40 in the Kinect data, so I was like, you know what, I just want to get a ton of information in here and start to see what happens, see what's interesting, see what I see in it. I think one of the first really interesting things to come of it was when we spatialized the data. So I took it out of that, these are very 2D experiences, right? It's 3D data, but I was sort of flattening it down, and I don't know if that was a bug or what was going on, but like the initial studies were very 2D, and I think the patterning was interesting, but I wanted more from the system, and when we sort of distorted this into 3D, it started to take on a whole different life and feel like an organism and be really interesting.
So it's up in layers, right? There's actual depth involved.
That video is really dark on my computer, which is really funny, but you can see me crawling around on it and doing weird dance moves. There must be a trove of funny people doing funny stuff in their Kinect cameras all the time. But anyway, those forms were really interesting to me, these distortions that I could get from the data. I did a bunch of experiments with trails. One of the early pieces you saw with that big blue thing that was moving around. I'm interested in the history of objects as they move through space. I did some studies here. I think it was kind of interesting, but I moved away from the trails in favor of this ability to sort of leave little things in space as I got data from those points. So it was a departure from the, hey, we're going to look at the path of an object through space, and it became a, hey, we're going to leave a little memory of this data point in space and let it sort of fall off the page, kind of like leaves falling off a tree.
I think just like one point to emphasize is that no one from the Arboretum came to us and said, we want this. They just said, here's a space, put something in it. And so this guy's over here, experimenting and trying to figure out what will be interesting, what will be engaging, what will be exciting in that space. So it's very much, it's not a well-defined problem that we're trying to solve. It's very much an exploration. It's something to discover.
I mean, that's one of my favorite roles as the artist, right? Is to be able to go off and do whatever I please and follow inspiration and not really know where we're going to end up. And one of the great things about Justin, and I think that you can do as an engineer if you're coming at this from the engineering standpoint, is to sort of just trust the person that even if they don't have a good data-based, factual, well thought out reason for something, there still might be validity to it. And in fact, there often is validity to it. And so to trust somebody enough to say, okay, like, I don't think that's right. Like, logically, what you're telling me,
why would you want to do that?
Yeah, we have these conversations a bunch, and every once in a while I just pull the, like, okay, you're going to have to trust me on this one. Like, just get me to this thing, and I think we'll see the result that we're looking for. Vice versa, I have to listen to him a lot of the time, too, right? Sometimes I'm like, yeah, we're going to do this thing. He's just like, no, it's not going to happen. You're just not going to. You're not going to create like a 4D fluid simulation that's running in processing in the next 2 days, right?
MacBook 13-inch.
Yeah, it's not going to happen. So, like, there has to be a mutual respect, right? A mutual conversation.
But a lot of it is definitely like laying this framework that kind of increases that search space for discoverability, right? Like, what you're looking at here is, there's this guy standing in front of a Kinect doing weird dance moves, and you have the Kinect feeding that data to your program, right? How do you take that data and create something like this, right?
Or why would you even do that?
Right, exactly. The choice of triangles, the color choices, the kaleidoscope idea, those are all choices that kind of like increase your search space, and you can start to tune the parameters in that space to produce interesting results. I feel like one of my biggest roles in not just work, but this, artistic pairing is like, let's make that search space bigger. Let's give him the ability to tweak all these parameters to do, create these amazing things, right?
Yeah, and this was one of the first places that Justin came into this project, actually. He'd been there all along. We'd been having conceptual conversations about what would be cool to do. But, prior to this, I was dealing with, I think this was a jump from like 40K triangles per second at like 20 frames a second. Up to I think we were at like 40 or 60 at 60 frames a second at this point. And this is the first
I think so.
This is the first incarnation of this project, and it ended up with Chandler Ahrens. I'm not sure if anyone's in the architecture department, but he used to teach here. He teaches in St. Louis now and has a office called Open Source Architecture. Chandler reached out to me about, they had this idea to build this space where they projected through a bunch of transparent screens, and they had an idea to use this older piece that I'd had, but I said, hey, Justin and I are working on this. Justin just got this great frame rate bump on it. Like, why don't we try it? Why don't we try it at this fair in St. Louis that you're doing? And we did, and yeah, it was a lot of fun. We learned a bunch of neat things about the project, and yeah, there were some things that I think were really successful, like some of the layering and the movement and the definition of space that they were able to attain with these structures. But then there were some things that I think could have been more successful, like I'm not sure we got quite the density that we wanted in the layered fabrics and things like that. Like I think the volume of space that the projection occupied could have been handled maybe in a slightly different way. So we'd love to work with them again at some point. They're really fantastic, and they've got a great office.
I would say that I think it's actually really important and good that we were able to put that out there, even though we didn't really consider it a finished product. A lot of times I view programming more like writing essays, so everyone's familiar with the essay writing process, right? You do a rough draft, you submit it, you get feedback, you refactor your essay, right? You submit it again, you get more feedback, you refactor it, right? It's not, you don't necessarily just divine the finished product right from the start, right? It's an iterative process that takes some time. And like this, we weren't quite done with it, but we were happy with what we had, and so
Yeah, deadlines are a good thing. Like deadlines make stuff happen. So this was probably not. Yeah, I think we probably knew it wasn't quite finished, and we were probably happy that we had another after this to keep doing dev for the Arboretum show. But it was a big step, and it got out there, and it generated a bunch of interesting conversation. So after that, here's me and my role as the artist again. Like I just loved messing around with the system and taking inspiration from it, rethinking, trying a bunch of different things. There's Justin. This is the look I always get. I put this picture in here because, like, number one, it's all been pictures of me, but number two, I'm always like, hey, and he's like, dude, okay, and then we do it, and it comes across. But
It's typically him complaining about his frame rate.
yeah,
issues.
that's the general start of the conversation. And Justin then looks at the code and is like, dude, what are you even thinking here? Like, why would you do this with this array? And that's not practical at all. And wait, what are you doing to the VBO? You're updating it every frame? Like, and so anyway, yeah, those conversations were really good. I mean, has anybody paired with a designer before, like designer engineer before? Okay, good. So did you guys run into some difficulties? Like, yeah.
Does that, do you mean like if we try with another designer to work on stuff?
Yeah, like paired on a project. So,
Yeah, and yeah.
Yeah, so there's a bunch of things like, how do you read the other person's code? Like, what on earth is this random variable called T2734? Like, I have no idea what that is. Like, there's a bunch of lessons that are really fun to learn. I think variable naming, so when I do code as an artist, it'd be interesting if we each gave our perspective, but as an artist, I do something, I know I'm making a mess. Like, I know it's not gonna pass. I know an engineer's gonna look at it and just be like, yeah, but like that's part of the role, right? Like, I can be a mess because the thing on the screen looks really interesting and it's a neat direction towards what I want. So I have to go into it sort of knowing that number one, okay, my code's not like there's probably a way better way to approach this from an engineering standpoint. But number two, how do I leave some breadcrumbs for Justin to even understand what on earth's going on in my systems? And that's everything from trying to organize my code in an interesting, good way to good variable naming to good comments, which I probably don't do enough. But
I mean, I think an important skill for everyone here is to, gain the ability to look at someone else's code and make heads or tails of it. If any of you are planning on becoming software developers after college, you will be thrown into a code base that you didn't write, and you may have problems with it. But you're not there to critique the code. You're there to provide value to it and improve it, extend it. In your ideal world, the code would be better, but that's not always the case. So it's an important skill to develop.
yeah, there's a certain humility. I think that's the right word to approach other people's code with, and I'm awful at it. I'm so bad.
It's important to have empathy. You have to realize that the person that wrote this system didn't have the same aims that you have, right? They had some other deadline, they had some other constraints to work within, and it's important for you as a developer coming on, rather than saying, oh, I would have done this, or, oh, that's stupid, why'd you do that? It's important to say, okay, well, we can make improvements, right? We can make it better. It's no need to point the finger and place blame. You should have empathy for other people that worked on that system and say, okay, let's make it better. Let's work with what we got, right? I think that's a really important skill to have, and it's not something that anyone taught to me as an undergraduate. Go ahead, sorry.
Yeah, so how do you think if you work with the designer who doesn't know the code?
Sorry, say that one more time?
How do you work with someone who doesn't know the code?
Yeah.
Oh, how do you work with someone that doesn't know the code?
Are you talking about just knowing the programming language or the environment, or just the actual code base?
I mean, if, for example,
you mean working with someone really non-technical that just really...
Okay.
Yeah, so in my opinion, it's on you to develop tools and workflows for that person. It's kind of on you to set up a framework of success, right? You want to create a pit of success where if they fall into it, they're always going to succeed, right? It's hard. It's hard to describe exactly what I mean by that, right? But they're not technical. They're not going to be able to program. If they can't program and they're not technical, it really is on you to develop non-technical workflows for them to succeed. Yeah.
I'm just smiling because it's you also find people like the stuff he does is beyond me engineering wise. Like I sort of understand it conceptually.
Just barely. I think anyone could learn it if they wanted to. Again, it all comes down to having different aims, different goals, right? Different objectives.
Well, there's different things that I want to be pursuing and interested. I'd rather spend my time dealing with some visual variation or complexity as opposed to the code base that allows me to get the 60 frames a second I need. Yeah, I agree. I always make an effort to overall understand to understand conceptually what's going on, but the details of an algorithm or a method, like I might not follow all of. I know what it does, but I might not. I probably wouldn't be able to recreate it for you from memory. But
yeah, I think an important takeaway is that there's like a place for you in the nitty gritty, right? Like I think I suspect a lot of people here are in computer science because they like solving technical problems, right? There's these, computer science is somewhat of a framework with a bunch of technically challenging problems, and you get to solve them, and it feels rewarding to solve technically challenging problems, right? It just feels good. Like I don't know how else to describe it. I think what an important takeaway is there's a place for you even in creative endeavors like this, right? There's all kinds of technical problems to be solved, all kinds of little frameworks that you can make progress in and make better improvements, to.
an incredibly valuable place too, right? Because I can't do. You find someone who's appreciative of you too, right? Because I know this project wouldn't be what it is without him. Like, it would be, it would be
10 triangles at 10 frames per second.
It would if we were with the original version. Yeah. So, that to find someone, I have a huge appreciation for what he does and what he brings to the project, and it's been funny as we sort of work together more. Our perspectives grow, and he's like. Just last week, we're doing some immersive design thing, and Justin's like, "Well, how about we do this?" And I'm like, "Oh man, yeah, that's better than what I thought of." And like, I'm like, "Okay, well, I'm just gonna go home because you don't need me anymore." No, but like it's awesome because like each of us sort of grows. I become more capable in terms of the coding and engineering side too, and then we do even cooler, neater things because I can prototype at a higher level, and he can come in and just like again step it up and build and collaborate.
Did that answer your question? We went off on a tangent at the end, but
I think.
If you want to talk specifics, we could talk about like specific examples. But I definitely feel like the onus is on you to provide the tooling and infrastructure for them to be productive, right? If they can't contribute there, then you're at a dead end.
And the artist designer needs to be able to describe what they're looking for in a clear way with obvious goals and an outline, right?
Yeah.
Like that. There's a big onus on me as well to be like. I can't just come up to him and be like, "This is broken," right? Because he's like,
"What's broken? Like, what do you want to do?"
I mean, what's the issue, right? He's like, "Okay, you've got a giant pink thing. Like, is that what you want?" Like,
your non-technical artist friend needs to have a vision that they lay out for you and describe the things they want to be able to accomplish, right? And then it's on you to kind of build up that framework that allows them to accomplish those things. At least that's my take on it.
Yeah.
I'd like to know what are the programs that you use for your coding?
So a lot. Well, yeah. I mean, a lot of the stuff we've seen, the big immersive stuff with a ton of screens, is all that Oblong stuff is C++, and
a lot of OpenGL. So computer graphics is really important. So is your linear algebra.
Yeah, and a framework.
Linear algebra. You won't regret it, I promise you.
In the GSpeak spatial operating environment, which is sort of proprietary software that Oblong's developed that makes all this spatial computing stuff really accessible.
Okay.
And then this kind of stuff is all processing and OpenGL. I mean, one of the things.
Processing is it's a Java-based creative coding environment, framework, if you will.
And Justin, one of the first things he did was dragged a lot of code out of my processing Java environment into a shader environments, which gave us huge bumps.
And so you say like Java, like what are these coding things you said you use? Java?
So processing, so PR.
Processing is the big one.
Yeah, processing.org is
something even probably more accessible is processing.js. It's a JavaScript environment for. It's the processing framework in JavaScript.
Do you guys know Lauren McCarthy at UCLA? Okay, she's an incredible artist, but also really talented programmer. She started Processing.js, which is an online version of processing that allows you to do really amazing JavaScript-based Canvas development. So.
you don't have to really consider, you don't have to worry about your text editor, you don't have to worry about compiling your Java program. It's all web-based and a little bit more user-friendly.
Kate Hollenbach's a big driving factor on that project as well. She's
a contributor.
Yeah.
So do you guys ever use programs like Grasshopper or?
Yeah.
Those are specific to architecture.
Yeah.
Those
I mean, back in my architecture days, a little bit, but not. Yeah,
I
not
see.
so much.
Okay,
So
interesting.
a lot of stuff we're doing now is pretty low level.
It's all
Yeah.
custom built. Everything you see was programmed to do that thing. There was code written by him or myself to do that thing.
Oh, I see. Like whereas Grasshopper is more like geometry and creating like forms kind of thing. This is more creating visualizations that are pixelated, that are like, visuals that you can, like that are data on a screen rather than data on like a form thing.
Yeah, so like a lot of tools like Grasshoppers have you creating these 3D models
Okay.
that ends up exporting to a file that then a program like ours, or I mean not necessarily this program, but you can write a program in one of these languages and import that model to visualize it in some interesting way. A lot of those tools though are meant for artists and designers, right?
I see.
That that you'll all have to work with, and that's part of that workflow of success that I was talking about, right? Like, designers are going to be using tools that you're not familiar with. They're going to be exporting to file formats that you may not be familiar with, right? It's kind of on you to write a program that's able to, hey, then import that file format and do something with it. You may not even, you might not be aware of what that file format is, but you can figure it out, right? You have Google. Sorry.
For the latent algebra, how long did it take you to kind of learn about it?
I mean, I took a class on it. I really liked it, so.
Was it better than calculus?
Was it better than calculus? It has elements of calculus in it, depending on what you take. I had a pure math degree, so it was all very proof based, not a lot of application. At least if you're doing video game type development or creative coding, you'll run into linear algebra a lot. I mean, most of what you're seeing is a lot of matrix multiplications. Computer graphics is just filled with linear algebra, so it'll pay off. Even just being vaguely familiar with a lot of the terms, it'll allow you to quickly recognize what's important and what's not. You can quickly refresh yourself if you need, or refresh yourself on various linear algebra terms when they need to come up.
When you use like Arduino,
Yeah.
what are you also using like Java and processing? Because I've only used Arduino with Grasshopper.
Yeah.
So
we have a I think that's all TCP based communication.
The Arduino it's interesting, right? We kind of consider the Arduino more of an input device. It's not central to the system, so there'll be some. Yeah, the Arduino is basically just this tiny self-contained system that does some computation connected to an input device, and we typically the result off to a different computer to end up using.
Okay, so it's just a data collector.
Sort of, yeah. It's just another input device to the system. That's typically how we use them.
Like that glove thing where you were like expressing to the computer and.
Yeah. These are just more snapshots of the piece. You can see, I should have a side-by-side, but there's a lot more geometry in some of these screen grabs than what we saw earlier.
Yeah.
So that was my contribution to the project, was John saying, I have 10 triangles at 10 FPS, I want, hundreds of thousands of triangles at 60 FPS, let's make this happen.
Yeah, so these are all just fun little studies from the work as I was going through it and seeing what I could do, what kind of visual effects I could get. I mean, this is one of the roles as the artist is to just push things and see what happens and what kind of results you get. We showed this piece and a friend in Germany saw it. I used Peitner, and he said, "Hey, do you think you could match sort of the styling that we have and do something for us in this jewelry show in Germany?" And we were like, "Yeah, I think I got you." So we took this work and did some of these color studies and variations on it, and ended up with a similar piece that we showed at the jewelry fair. And This guy's great. I have no idea who this guy is. I wish I could get him to come to all of our installations, but like, he's like, we got this video with him, and he was just incredible. He kind of ran around.
This entire project was really interesting studying user design because, so like, right, we have this like projection wall, and then the Kinect's like over here facing this way, and a lot of people would be like right up on the wall doing this, not aware that the sensor was back there. Really, what we wanted people to do was like stand in front of the sensor and be weird. But instead, a lot of people just end up like running right up to the wall and acting funny. That's kind of on us. We didn't really, we didn't really consider that. It was interesting to watch. We got to watch all sorts of. It was really great people watching. That's
that's
a better word.
So when we did that, we were like, we want more of a one-to-one connection. We were interested in the body, and people being able to see themselves a bit more in the work, and so. The jewelry fair came back and really liked the piece and was like, well, can you guys do another version of it for us? And we said, oh, sure, great, let's do it. And we, of course, being the artist designers that we are, we were like, okay, well, let's start over pretty much from scratch and approach this again. And started doing these sort of very form-based versions. I think Justin also made some upgrades at this point, so I was using all 640 by 40 pixels. And I was able to get these really neat organic forms that we're moving around. And again, this goes back to some of the early stuff we're doing, right? Like I did start over again, but I reused a lot of the kaleidoscopic based stuff. And I was really interested in how the human form could sort of evolve and come out of this and then fade back away into the background. At the same time, I've been doing these spherical studies, partially with Oblong and kind of partially also on my own time to continue to explore them. And we were looking at spheres as interfaces in these systems. One of the neat things about the work at Oblong, I'm starting to think about geometry in new ways. So spheres are really interesting in an immersive room because you can put them off in space, get a sort of 3D view of it, and then you can pull it around you and immerse yourself in it and get a kind of interesting 2D view of it. We'll look at that more later. But I was like, ooh, I wonder if I can apply these spheres to the work we're doing. And that led to some interesting sort of jumps in this work. I started wrapping the Kinect data to a sphere, and that was pretty interesting. I was pretty excited about this result. But the next thing we did was start to distort and wrap those movements in kind of entirely new ways. So there's a bit more abstraction here. I'm warping the data as it's wrapped around the sphere, but it resulted in a bunch of these really neat forms that I just hadn't seen or experienced before. And this was the next version for the piece. Again, I don't know how he gets these incredible people to come and just dance in front of the work, but it was really fantastic. And so he sent me this video, and I was like, oh, it's amazing. And then he got another person in there, and I can't tell if he's in here or not. I think he might be the third person now that there's a bunch of dancing in a second. I think that might be him right there in the middle. But he's a really great guy, and he sort of did the whole installation, installed it all, coordinated it all with the layout design. And yeah, it was really fun. And I got some of the things we're going after, right? We got the human body, we got an immersive system, we got interactivity. I think we engaged people better in this one. And it was a fun sort of piece to go with. And then we got a bunch of these really fun moments where, Justin mentioned earlier about people just going right up to the wall and wanting to stand there and move and do things. And so we calibrated this one better so that they could go right up. I mean, to a certain extent, the Arboretum was a little tricky because we were like, 60 feet away from the wall or something like that, and it was on an angle. And so here, we had a lot more controlled environment, and we could calibrate it right up to that wall and make sure we could get these interactions. Going a little quickly so we can get through to some of the last stuff. Okay, and so I just wanted to end by looking at some of our work at Oblong, and
kind of shown like, hey, you can have fun doing artistic stuff, but you can also get paid to do cool artistic stuff and be technical.
Yeah, and the stuff informs both, and it's equally fun and beautiful and magical and human and inspiring. So. And even more, like I said a while ago at the beginning of the talk, when I started at Oblong, I felt like all of a sudden I had all these incredible tools and capabilities opened up for me. All of a sudden, I could deploy an application, I could write an application for space like I'd been doing, but all of a sudden put it in the middle of 90 million pixels running on 45 screens, 93 million, yeah. 93 million pixels, 5 computers. And it's kind of amazing to be inside of these spaces. And you know, so we hit on this a little bit earlier, right? We define screens based on their position and orientation in space and their resolution, right? And so this is just a little sketch of like a potential center. I think this is actually pretty close to what we did. We do our stuff based in millimeters, and as long as the computers know how many screens they have, where they are, how they're oriented, and what their resolution is, GSpeak handles everything else for me. So it's fairly liberating to create these really incredible, magical experiences. This was at like 3 a.m. in New York after it was a long day. We finally got we finally got it installed and working, and like we were playing Celebrate because it was very appropriate. But you can do these really incredible spatial things in the space. Remember, I was talking about putting things off in space and being able to view them in a 3D way, and then immersing yourself in them and getting kind of a more 2D perspective. This is a data visualization that's looking at different companies and different factors associated with those companies. It's a big, basically sorting algorithm navigation system. This is another prototype where we explore a similar idea. This is looking at a bunch of sort of 13 metrics of client data for a distributor, and tried a bunch of different things in the space. And it's fun because when you design and develop in this ship of the imagination, all of a sudden you start doing things and seeing things in a new way, and thinking about how I can use intersections.
Putting yourself in the center of this whole system.
Yeah, all of a sudden it goes from this big 3D Death Star to like a 2D Excel spreadsheet, sort of, but prettier. And like, just that ability to immerse yourself in it, you start to see new patterns, new things. Real quickly, this is an abstraction of the data just because it was client data, but with the real data, you can look at it and see patterns and see areas where things are going on, and look at things that you want to sort of explore further and look at. This is a really fun one. This is Hipparcos and Kepler data, and it's looking at stars in the solar system, and more specifically, stars that have exoplanets associated with them. There's a really amazing piece that Jer Thorpe and Oblong did 10 years ago now, and looking at the Kepler data, and we had a project where we had the opportunity to re-explore that data. And it was really, the scale you're dealing with in this space is really incredible. I think one of the neat things about immersive systems like this is it does allow us to deal with all sorts of different scales, from, you know, the heart data, which is the thickness of a couple of human hairs early on, to this you know, this system that's thousands of light years across, and being able to create these environments where we can explore all those scales and times is a really exciting thing. And interact with it, yeah. Write code to be able to have intuitive interactions with it. This is that hard data again. I think we're about at the end. And you know, I said earlier, when you have a real direct, responsive spatial interaction with a virtual system, you get attached to it in a really unique, interesting way. That's one of the first things I got really shocked at working at Oblong. And it becomes really intuitive and natural to interact with these spatial systems. So that ability to spatially interact with a spatial system is really exciting and beautiful and natural and human, which were some of the original goals of the work we're doing. And again, this is just a recent test too, where we were looking at proximity and long direction based interaction. The idea might be that you could explore additional metadata with the system as you navigate through it and walk through it, right? You might expose genetic information for, or genetic expression for the cell lines that you're kind of closest to.
It also just looks cool. And
it looks cool, and it's fun. I love shooting the space at nighttime because like all you can see is the screen and the outline of the person, and it's just, yeah, it's a lot of fun. Yeah, so that's it. I'll go back to the first slide so we can kind of see all the information again. I know we don't have much time, but we're happy to answer questions or stick around for a little bit.
I was wondering if you could show us the data set.
Yeah.
You have a data set, because you've been talking about data so much, and we've been seeing all your visualizations. I was wondering if you have a set of data around there.
Let's see here. Yeah, I think we have.
Maybe
maybe while you're looking for it, if you can find anything,
Yeah.
I have a question about communicating. Let's say if you're creating a library of gestures, or if you have a specific way that your clients then need to interact with what you're creating. So how do you communicate that with your clients? Because sometimes I'm not sure how many, let's say, gesture-based commercial projects you've executed. Because one of the things that I think becomes quite difficult, so for instance, when Leap Motion was first introduced, knowing what the initial gestures are, then it could be confusing. So do you present a diagram? Do you train people?
So yeah, the direct answer to your question is we typically do trainings. So the users of our, at Oblong, the users of our systems are, we're not releasing the software to the general public. It's not like anyone comes up to the system and interacts with it. Our clients have a select few employees that end up interacting with the systems, and we train them on how to, what the gestures are, what the interactions are, and so they kind of know before they start using the system what all those interactions are.
And do you take their input, I guess, throughout the creative process as well?
We do, and that was actually an iterative process. At the beginning, we kind of stormed in, and we were the ones creating the gestures and the interactions, and we got feedback that, hey, some of these gestures or interactions are difficult to do in front of clients, or they aren't necessarily robust. So sometimes we have this, I'll pretend this is the one, a common gesture we do is like push and pull back, where maybe once you cross some threshold, some imaginary threshold, let's say, I don't know, half a meter, we want some pixels to trigger on the screen to do something, right? We have people that they're standing in front of a space of 20 executives, and they're nervous and they make mistakes, and so sometimes they maybe don't go half that meter, they go there, and then the system doesn't respond. And so in their mind, it's like, oh, that's a bug. You wrote something, you gave us something broken, right? Or they're embarrassed in front of a client. So getting back to your question, it was very much an iterative process, and we got feedback, and we said, okay, like here's, maybe we can't do that anymore. We have to adjust this gesture to make it easier for them to use. Right. Does that answer your question?
Yeah, absolutely.
Okay.
Thank you.
Yeah, so this is that data. It's running a little slow, I think, because I'm sharing my screen. Yeah, it's just a bunch of, I'm trying to remember all my commands for everything too off the top of my head, which I'm not doing very well. But this is that quail heart data.
Can you show the CSV file? So at the end of the day, like this is his visualization of it, but there's a CSV file backing it. Something you can open up in Excel.
Oh, is that what you're asking?
Exactly.
Okay,
Yeah,
cool.
it's literally a table of numbers.
Yeah, our students, they in my class, they just started doing their first data viz last week. It's due tomorrow, actually.
Oh, cool.
And they were creating their own data set, and I was wondering, since your data visualizations are so beautiful, it would be great to see
Looks like that.
what the connections are.
Yeah, that's it right there. Oops. There we go.
So was it this doctor at CHLA, this doctor who gave you the data of the heart, the progression, and then you plugged in that data into that coding?
Yeah, well, there were a bunch of conversations to get the data in a format that was ideal, because he was using MATLAB and a bunch of stuff too. So there were a bunch of conversations first on like, okay, well, this is the stuff that's most useful to me right now. Yeah, a lot of it, I mean, he already had some ideas. There's precedence in data visualization, right? So we started with some good ideas on how we were going to approach it, but then a lot of that artistic side came in where I was like, okay, let's do triangles everywhere, because it was funny, we were working on stuff at the same time, and I'm like, yeah, I like triangles, plus triangles are easy with the rendering system, right? So plus triangles give me directionality, and I was like, yeah, cool, okay, let's use directionality, and let's, I've got each previous point of motion, so let's make my triangle sized based on how far I'm moving. So I get a sense of velocity based on the triangle size.
Let's make color mean something.
Yeah, all right.
What does color represent?
So based on its actual 3D orientation, let's color it differently and assign some different hue to it. So all of that grows out of lots of exploration in these sort of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns of data. So, and this isn't even all the data, but it was a good starting point for us. Sorry, I misunderstood, but yeah. Is that, yeah, so I have 2 data sets like this. There's a couple of stainings on them. But yeah.
And so you don't need to open your script in order to play your and like change your is it like your the simulation and all that, and like moving it around and making it change to different things. You don't need to open your script to be able to do that, right? Because you were moving it around and you were changing stuff. You weren't editing the script.
Yeah, that's right. So I had a
John basically wrote a program that reads in this file, iterates through all the data, loads it into various data structures, and then comes up with a visual representation of it. And it's that visual representation that you then program various interactions to update that visualization.
Okay, so then you just like, you know, maybe click on something or edit a key, and then it'll change out to like a different type of data.
Yeah. So I always joke that like it's programming. We can do whatever you want to do. We can do. I mean, obviously that's not true to some extent, but
it's annoying when you're really tired and asking just for like a question, can we do something? And it's like, yeah, of course we can, but like it's gonna take me a week, and I'm like, well, all right, so we can't do it by tomorrow.
But I guess like more to your point, or more to your question, kind of everything you see has been hand programmed. Like there's a line of code to do everything you see there, and it's really, there's infinite possibilities in some sense. The search space is infinite, right? Like it's a blank canvas. You're writing an essay. What are you going to write? It's very much comes down to what the vision is and what you're trying to accomplish.
Should we do one last question?
Yeah.
I'm just curious about like how many lines of code do you think that took? Just as like a fun question.
Which one?
How many?
Which? So
the heart visualization?
Yeah.
The heart is the main code is 247 for the main. The dataset class is 309. It's not too bad. It's pretty. The lines. But the data points are. Yeah, there's a lot of data.
Oh, that's good.
So the data is. Okay, so the data loaded 290,000 plus 169,000. And then I'm like, yeah, so that's rows of data, but they're shared traces and things like that. So, yeah, that's not that ridiculous, and like, that's actually pretty low on like what the amount of data we're actually collecting is. So I'm lucky. It was a kind of a nicely sized data set.
Yeah, I think one important takeaway is that when it comes, there's not a lot of, how should I say this? It comes to a certain point where there's not a lot of black boxes that just do things for you magically. It's on you to program it. So I think that's, I think a lot of people here are very technical, and there's a lot of opportunity for you to, apply that technical expertise into, problem areas like this.
All right. With that, let's really thank John and Justin for their amazing inspirational lecture. A lot of pressure on you guys for your, database assignment tomorrow, and thank you so much again.
Thanks for all the opportunity and all the great questions and conversations. So I didn't write. We didn't write emails up there, I don't think. But look us up on Instagram or our website. I think I have my email address on the website, or it's johnbcarpenter@gmail.com.
What programming languages are you guys using for your database?
They all have your website as part of their assignment.
Okay, awesome.
So.
You guys like Python?
Oh, jeez. We did some like P5 and stuff too, and
Okay.
cases.
Yeah.
P5 is a nice environment.
Yeah, that's fine.
Python's reading other people's Python is kind of a little hairy sometimes, a little scary, right? But writing your own Python should be fun. It's a fairly flexible little programming language.
Yeah.
I think the only programming like that, like coding I've ever done in my life is probably like customizing my MySpace page.
Well, that
No,
counts.
that's actually, it's very much related. It's not all that dissimilar.
MySpace still around?
No, it's not, and I'm bummed because that was like a good way for kids to like experience like what writing stuff and numbers and everything really is.
What Python library are you guys using to actually do the visualization?
We use a touch designer, like
They're doing it with-
rendering.
Sorry. Keep talking.
Sorry, what was it?
So we use a software called touch designer.
But you
Touch designer, yeah.
but you guys also use Python, right, for different classes.
Does Touch Designer have scripting capabilities in Python?
Yeah.
Okay, cool.
It's node-based like program that you can code in.
I haven't done anything to Touch Designer, have you?
No, I keep hearing about it though. I keep asking people how they did something, and they're like, "Oh, I did that in Touch Designer." I'm like, I need to look at that. So this is like the fit.
Actually, where I work, we primarily use Touch Designer,
Oh,
and like a CSV file like that, you just pop it in Touch Designer.
Oh,
You can like immediately start manipulating the data, like doing instancing and things like that.
Nice.
Anna is a master of Touch Designer.
oh, right. Okay, cool. Yeah, that's great. All right, well, let us know when you give a talk so we can come learn about it.